Hello everyone and welcome back. So in this tutorial we are going to talk about a stack. Now, what is a stack? So let me explain what a stack is. A stack is simply a data structure. A data structure. So what you would do, you could have, let's say, plates. If you're stacking up plates, you would have the first plate, the second plate, let's say that, the third plate, you can have the fourth plate, and so on and so forth. Now in a stack, it is that in a stack it's that the last element you add, or the last plate you add, it will be the first plate to get out. So it works in the principle of last in, first out, meaning that the last one, the last that you add is the first. It's the first that leaves. That's the principle that it works with. So to do that, to code a stack, we shall need to create a new file. So we're coding a stack in Python. We'll have to create a new file. So after creating the new file, let's save it somewhere, and you can save it as stack.py. So what do we need? We need a node. So we need to create code the node. So we shall say class node. Then a node needs to have the data. It needs to store data. Needs to point to the next node. So we shall set define. We shall initialize. We shall initialize our class with self. Then it passes in data. Then from there we shall say let our self dot data equal to data. And let our self dot next. It's going to be the next pointing to the next node. Let our self dot next equal to none for now. Then we are going to define our class of a stack. So our stack will need some functions. So we will need a function to check if the stack is empty. Take in self. I'm going to say pass. It will need a pick function to just return for me the data of the last element to enter into the stack. So just say self, then pass. Then we need another function to add information onto the stack. So I'll say define add, then I'm going to pass in self, then the data that we need to add, then I'll say pass. Then we need another function to remove information from the stack. So I'll say remove. So remember, when you remove information from a stack, you need to delete the top node, meaning that the last node to enter is the one where you remove the information from, and then you need to delete it from the stack. So I'll say pass. So now, what do we need to keep track of in a stack? So in a stack, since you are stacking up, let's say nodes, the first node, second node, third node. So this may be the first node, second node, third node, fourth node. So all we need to keep track of is this top node. That's the only thing we need to keep track. This is called the top node, and maybe this could be called the head node. But all we need to keep track of the top node, because the top node is whereby from the top node we can add new information onto the top node, and then from the top node is where you can remove information from. So all we need to keep track of is the top node. So to keep track of the top node, we shall have to first initialize our stack function. Do so, we shall call def init, then we shall say self, then we shall after calling self, then we shall say self dot top should equal to none initially. So to check if the stack is empty, we shall just check if self.top is equal to none, then it is empty. So if it is empty, then we shall maybe do something. Let's say print. I can print empty. pick. So to pick meaning that just look into the stack. What is it? Data. That's the data from the top element onto the stack. So to do so, we can just return self.top.data. So then, what if we wanted to add information onto the stack? So then we shall come, pass in the data, then we shall create our new node, which will equal to node, then we pass in the data. Then from there we shall check if self.top is equal to none, self.top is equal to none, then our self.top will equal to the new node, then we return, meaning that we end there. What if self.top is not equal to none? So if self.top is not equal to none, what we shall do, we shall select self.top.next equal to the new node. Then now we need to now set our top node. Our top node is now the new node. So we shall say our self.top will equal to new node. So that's how you add information onto a stack. What if we wanted to remove information? So then we shall just select data equal to none. Then we shall say if data is equal to none, we shall say if self.top is not equal to, if self.top is not equal to none, because if self.top is equal to none, there is no information on this stack, so there is no data to be retrieved. But if self.top is equal to none, what should I say? Let's data equal to self.top.data. Then we shall select self.top equal to self.top.next, meaning that now since we have removed data from the top node, now we need to set the top node to be the what? The next node. So our self.top will equal to our self.top.next. Then from there, what we shall do, from there we shall return our data. Probably, yeah, yes. Then from there we shall return our data. So that's how you make. That's how you make a what? That's how you make a stack. Thank you for watching. If you enjoyed this video, please leave a like, leave a comment, subscribe to the channel. Thank you again for watching.